Hi viewers, this video explains about the implementation of stack by using the linked list. Earlier video explains about the stack implementation by using the array, but now we are going to implement the stack by using linked list data structure. So basic implementation, we should check the list is empty or not. Then push method, which is used to add a new data item into the starting of the list, beginning of the linked list. And then pop method is remove the data item from the head node, from the head of the list, or starting or beginning of the stack. So since we are using the linked list, I mentioned the list. Here the advantage is, uh, it is it requires only constant time to push or pop the element, because for inserting the data into beginning of the list and removing the data from beginning of the linked list needs only order of one time complexity. And the size of the stack here, the linked list characteristic is we can change the linked list size during the runtime. So we can add the data item and remove the data item, so changing the linked list size in the stack infinitely. Okay, we can keep on insert the data item by changing the size. I mean, we need not to change, so dynamically the linked list size will change, so stack size also will change dynamically during the runtime. Disadvantage is, which is slowest of all the implementation, that means stack can be implemented by using array and also vectors. So among these three methods, the linked list implementation is slow because it is in need of pointers. That means address is pointing to other node, right? So now we will use push and pop operation at starting or head node of the list. New nodes should be inserted at beginning of the list. For example, if I am having the stack like this, so stack will be represented in this format. Okay, so here the first node is inserted, this one. So this is the memory location, let's take this is 0, right? Then this will point the address of next node. Sorry, this will point the address of next node, this will point the address of next node. Okay, this one, right? So this one, right? So this is the head node, so, so initially this is the head. So now head we are changing, so this is node number 2, memory location is 1, right? So this will have the address of previous head 0, right? So sorry, 10, so, yeah, 0 0. Okay, address of next node 0, so 0 is given here, this is the address of the previous node. So this will be the null because this is the last node. So whenever we want to insert node into the stack by using the linked list at starting of the starting of the stack, this is the top element. Now this is the top element. Now suppose if I want to insert one more element, then I can insert on top of this. So this will represent the node number 2, which is available in the memory location 1. So memory location 1 will be written here, this data may be a 10. So now the head is updated, so this new node will become the head. So only we can insert the no data at the top of the stack. So now this is the top is updated. Like that, when you want to apply the pop, okay, pop operation, it will remove top element first. So head will become head dot next, so what is the head dot next? The element number, the address number 1. You look at this, address number 1 is the head dot next, so head will become the this one. So the memory location 1 will become the new head. So automatically the top will be removed from the list, right? So this is the basic operations, and the push and pop operations can be implemented easily because we are using the head pointer. Okay, in the linked list always we will use the head pointer, right? Head pointer to represent the first node, so which is easy to access the first element of the linked list, right? That means stack. Here we have to say stack using the linked list, right? So using the head point, so this head point will be acting as a top in the stack. Here the stack is having in the form of linked list nodes. So here I am using the single linked list node which is having two fields, data field and address field, which is pointing the next node. So which is given here, the first we have inserted, so here push 2, then second time we are pushing 1. Okay, first for the push 2 we will create the node like this. Okay, so this is the null, this is 2, right? Memory location may be 105. Then when we are pushing 1, the it will insert at top of the stack. So push 1, so 1 is pushing, the address of the next field of the 1 will be 105. The link will be created like this. Link will be created like this. So this memory location may be 107, right? So this is the way to represent the push operation. So here the node is having two fields. Always the top variable is representing the head node. Okay, then the last node next field will have the value null, right? So this is the representation in stack by using the linked list. Here in Java we are creating the node in this structure. Okay, the structure is having two nodes, two fields. One is the data field, so we are declaring the variables. Here I am using the integer variable. Suppose if you want to use string or character or float, any data type, you can represent that. Then this is the address of next field, so which is representing next entire structure of the node again. So this is entire structure. Okay, so this, since it is representing entire structure, this next field is declaring as a entire node. Suppose if it is the 100, so the 100 will be written here. So entire structure of the node is represented by this next field. Then we are assigning the data into the data field. Then whenever we are creating the node, always data will be assigned here with some value, and this will be null. Then when during the push operation and pop operation, we will modify this value of next field, right? So that is the thing. Initially we are making the stack will be null. So null means there is no nodes available in the list. So list is representing the stack. So if it is no nodes, no data available in the stack, that means stack is empty. So this is the representation of stack by using the linked list. Thanks for watching.